Hi, this is Mrs. Whitaker. I'm about to start my video for tonight's lesson. Don't forget, tonight's lesson is kind of a mix of what we did this week. It's going to be a mix of what we did with lesson 1 when we were graphing inequalities. Remember, if your inequality is just a greater than or less than symbol, you're going to be having an open dot when you go to graph it. And if your inequality has a greater than equal sign below it or less than equal sign, it's going to be a closed in dot, which what that means is the number that's with the x can be included in the set of numbers that could be x. So that was from lesson 1, and then lesson 2 and 3 was when we were solving for x in our inequalities. So now we have a mix of lesson 2 because we're going to be solving for x and then we have to graph it. So lesson 1 and lesson 2 where we're solving for x. Now how do we solve for x? We have to look and see what's happening, what operation is involved with the x. And if it is addition, if that's what they're doing, then we need to do the inverse to get the x by itself so we can solve for it. And that would be subtraction. If it's subtraction, the inverse would be addition. If it's multiplication, the inverse is division. If it's division, then the inverse is multiplication. Okay, so looking at the first one, we would draw our line down, just like I told my students in class today, pretend like that less than symbol is an equal. Just pretend for a few minutes, and we're going to make that our equal place, and we're going to draw our line down and divide up a problem into the left side and the right side. And then that way we kind of can keep track of what we're doing on one side versus the other side. So I always want to start with the side that has the variable, which is this side. And I look at the variable and I say, okay, I need to get you by yourself. What is happening right now with the variable? I notice what's happening is it is addition. So how do I do the inverse of this, which would be subtraction? So I want to subtract, but what do I subtract? Do I subtract a 6 or do I subtract 9? If I subtract 9, that will not get rid of the 6, and I will still have something on the side with x. I want to get x by itself. To do that, I need to take 6 away from both sides. If I have 6 and take 6 away, I'm left with nothing. Nothing. So now I just have x left, and that's what I wanted. And again, we said let's put the equal sign there, but let's bring back the original sign, which was less than. And x is less than. And now on the right side, I didn't have a positive 6 on top. I have a positive 9. So they do not cancel out. What is 9? Take away 6. And if I work that out, I would get 3. 3. So now this is my inequality. And this is kind of like what you saw on Monday, where they would give you this and you had to graph it. So they gave you a line. You're going to put your numbers down below. So I'm going to have 3 because that's what's with the x. I said to put like 2 ahead and 2 below. That would be fine. Now I have to decide what kind of dot would go on a 3. Is it open dot or is it closed dot? Remember what we talked about in the beginning? Look for the symbols. I do not see an equal sign with my less than or greater than, so I'm going to have an open dot. So I go down here and I'm going to put an open dot at the 3, and I have to shade the direction on the line that could possibly be x. I am not going to shade to the right. If I shade to the right, that would include 4. If I plug in 4 here and think that 4 is x, 4 would not work because then I'm saying 4 is less than 3. So I do not want to shade in the direction of the 4. Instead, I want to go on the other side of the circle, and I want to shade maybe in the direction of the 2. So if I plugged in 2 here, would that make sense? Is 2 less than 3? Yes, that's true. So I want to shade in towards the 2. And on FSA, they're not going to really shade. They're just going to make this arrow look bigger than the other arrow. So that way you know and they know which way you should be going on your number line. Now, what does that mean? That means x could be 2, it could be 1, it could be 0, it could be -1, all the way back on the number line to the left. Now it cannot be 3. 3 could not be x because I do not see that equal sign below the inequality, the less than sign. So let's take a look at number 2. Number 2, same thing. Gotta pretend like this is an equal sign. This is my divider then. I have a left side and a right side. Where do I begin? You want to begin where your variable is. I want to begin on this side. Okay, what's happening with that x? I see a -4. If they're minusing 4, what would be the opposite of that? It would be adding 4. So I want to add 4 to both sides to be fair. Okay, so on the left side, if I take away 4 and I add 4, it cancels them out, and I'm only left with x. X, I'm going to put my original symbol. I'm not going to use an equal. X would be greater than or equal to. Now I see that line below. What's going to be on the right side? Well, I have to actually work it out. What would be 11 plus 4? It would be 15. So x could be greater than 15 or it could be equal to 15. So on my number line, I'm going to start with 15. I'm going to put 16, 17, 14, 13. I'm going to do a closed dot that shows that 15 could be x. So x could be 15. It could be, now, which way am I going to go? Am I going to shade towards the 16 or am I going to shade towards the 14? Well, if I plug in 16 for x, does that make sense? Is 16 with the mouth open towards 16 because he's bigger? Yes. So since that's true, I want to shade this direction. I want my x to be bigger than 15. So I'm going in the direction where the numbers are bigger than 15. So x could be 15, it could be 16, it could be 17, all the way to infinity. It could be x. So I tell my students in class that you need to be ready for what they can put in for x. It could be a multi-select. They could say A is 15, could 15 be x? They might say, could 14 be x? They might say, can 15.1 be x? They might say, can 14.9 be x? They might say, can -15 be x? So then you are supposed to select all the possible choices. And so in this case, you would actually select A because it had that equal sign. It could be 15. You would not select 14 because it did not end up on the side that you shaded. You could pick 15.1 because 15.1 would fall probably right about there. So yes, you would pick 15.1. Could you pick 14.9? No, because 14.9 is in front of the 15, so no. Would you pick -15? Well, -15 would be way back here somewhere, so you would not pick that. So it would just be A and C. So I kind of talked to students to prepare them that they need to know what x, all the different numbers that x could possibly be. Let's try to do a different kind of problem. If you look at, let's look at number 6. 6, again, I'm going to pretend like this is my equal sign, so my divider is here. Now, in the other problems we were doing, we had to find x, that's where we're starting, and we had to ask what was happening beside the x. And in the other problems, we were adding or we were subtracting. I don't see addition and subtraction right now. I see that they're side by side. And we've learned this year that if they're side by side, that means it's multiplying x times 11. How do I do the opposite of that? What's the inverse of that? Well, that would be x divided by 11. So I need to divide both sides by 11. So I would say divided by 11, divided by 11. These cancel out. Then x is less than or equal to, and then I have to say, what is 121 divided by 11? It's 11. So I'll go down to my number line. I write 11 do a couple numbers above, a couple numbers below, and now I have to decide which kind of dot am I going to place on the 11. Well, I see that equal sign right here, and that means 11 could be included as x. It doesn't have to be just less. It could be equal to also. So I want to do a closed-in dot. Okay, which way am I going to go? We'll plug in a number from each side. If I plug in 10, if I plug in 10, would that make sense? Would 10 work here? Yes, because 10 is less than 11. If I plug in 12, that would not work because 12 is not less than 11. So you want to shade in this direction, make this arrow look bigger. And so now that means anything that's on my shaded line could be x, including 11. So x could be 11, it could be 10, it could be 9, it could be -9, as long as you're getting smaller. So I hope this helps you with your problems. Number 8. Look at number 8. We haven't done one like this. So you're going to put a line down here. Look where your x is. What's happening to the x? Well, it looks like if it's got a line and 2 is below, that means they're dividing x by 2. They're dividing x by 2. How do I do the opposite of that? I'm going to take x, I'm going to multiply it by 2. So I multiply by 2, multiply by 2. And on the left side, 2 divided by 2 would cancel out. And I'm left with just x. X is greater than. Now look on the right, we have 3/4 times 2. Well, since I have a fraction here, I want to make him a fraction. It makes my life a little bit easier. So to do that, I put it over 1. Now, do I need to do keep, change, flip? Nope, because I am not dividing. I am just multiplying. So 3 times 2 is 6. 4 times 1 is 4. So my answer would be 6/4, or if you simplified it, it would be, you could divide both of them by 2, which would give you 3/2. Now, when you go to number line it, they usually don't put improper fractions on a number line. They've got whole numbers. So what that means is you might want to convert this back to a whole number. 3/2 would be the same as 1.5. I get that by just dividing the 2 into the 3. It goes in 1 time, and I would have 1 out of 2 left over. Now on your number line, you're going to put 1, 2, 3, and over here you'll put 0. Where would 1.5 work? It would fit right between the 1 and the 2. So I would put an open dot because I do not see that equal sign. I just see a less than sign. And which way am I going to shade? Well, whatever x is, it's got to be bigger than 3/2. So I'm going to get bigger. So I'm going to go this direction. So what does that mean x could be? X cannot be 1.5 because it's not equal to it, but it could be 2, it could be 3, it could be 4. It could actually even be 1, could be 1 and 3/4, because that would be bigger than 1.5. So, I think that's enough help with your homework tonight. If you have any questions, you can come see me in the morning. Don't forget, if you're dealing with decimals, same thing. You just have to line up your decimals if you're adding or subtracting. Okay? And don't forget on the back side, if you cannot see number 3, you just need to do 1 and 2. Okay? Have a good night.